So now let's take a look at how centralization works. Here we see a set of users who are responsible for managing devices. These could be individual routers as we see here, or they could be management devices that require visibility to traffic. The scenario requires that the users connect to individual devices to see problems on the network and to troubleshoot them. Each connection is a step for that user. This wastes time and money. Now contrast that with what we see here. Operators can get visibility to all the same traffic through a centralized interface. This means they save time and money by having a single step to view all traffic and troubleshoot multiple networks. This is possible through advanced techniques in filtering, selective aggregation, and packet slicing. Let's see what that would look like in a real IPTV network. What we're looking at here is an example of what a typical IPTV architecture would look like using the techniques I've discussed so far. We begin with the most important component of the architecture, the subscriber. Content is delivered to the subscriber via the access layer, or layer 2, where DSL technologies, fiber to the X, or even metropolitan area networks serve as the distribution mechanism to the customer. Content creation begins at the head ends for national content and potentially local video serving offices for local ad insertion, local content, and video on demand features such as those seen in layer 3. The content is distributed to each of these access networks via largely dispersed networks, or the core as it's often called. Now, if you're looking at this image and not one of our audio subscribers, you can see that there are small squares at each of the access points, the head ends, and the local video serving offices. These are the points where distributed traffic capture systems would typically be placed for visibility, as can be seen here in layer 4. Finally, we have the point where all devices are centrally viewing the traffic in layer 5. This is where application-specific monitoring tools, sniffers, intrusion detection and prevention systems, and any other tool may reside. Distributed traffic capture systems increase scalability through the use of aggregation, selective aggregation, filtering, and advanced packet slicing techniques. They also lower the total cost of ownership for management tools. This is accomplished primarily by reducing the number of tools, lowering capital expenditures, and by lowering operational costs. Because of the reduction in the number of tools, the ongoing maintenance for the management equipment is also significantly reduced. This has helped lower our customers' costs by up to 80% in year 1 alone. Distributed traffic capture systems also decrease the amount of time taken to solve problems by giving visibility to potentially all networks in a single location. Again, according to the Aberdeen Group, their studies show that this resulted in an overall improvement of 120% in application availability over organizations that do not use distributed traffic capture systems. Today I'll have with me one of the senior hardware engineers here at VSS to talk to us a bit about the 16x8 series. Thanks for joining me today.
You're welcome.
I've seen some pictures and now I finally get to see this new series you guys have been working on. From what I understand, this series has the highest port and rack density available for a distributed gigabit tap. Why don't you tell me a little bit about the 16x8 series?
Sure. This series has 16 network ports and 8 monitor ports.
So this is a gigabit tap only?
Actually, the copper 16x8 supports Ethernet, fast Ethernet, and gigabit speeds. The fiber 16x8s are gigabit only for the network ports. Both units use SFPs for the monitor side, so the customer can choose what they want to use.
A lot of network operators use span ports and don't necessarily want certain networks to have any devices in line. Can these devices accommodate them as well?
Well, that's a great thing about VSS Distributed Taps. The taps are able to function in either span or inline mode simultaneously. For those users who want to monitor span ports, we have span-only versions of the 16x8 available. These devices are fail-closed instead of open, thereby preventing any traffic leakage into the span ports.
I can't help but notice there are 2 network ports for every monitor port. Why is that?
Well, the reason we designed the distributed taps in this fashion is to help our customers efficiently scale their monitoring tools through useful features, like selective aggregation.
I was telling the audience about selective aggregation before. Can you explain it for me?
Sure. Selective aggregation allows users to determine what network traffic will be sent to a chosen monitor port.
Some of our users are concerned about oversubscription and don't necessarily want to aggregate. What can we do for them?
Well, first, you could, of course, reduce the amount of traffic you're sending from a set of network ports to a particular monitor port using selective aggregation. Secondly, if you're using a copper 16x8, it has 4 input-output ports. You can actually copy traffic without aggregation by using those additional 4 I/O ports as monitor ports instead of network ports.
Now, I've also heard rumors about a new management module. Is that true?
It is true, and it's very exciting. The new VSS Distributed Management module is part of all new devices, like the 16x8 series. We actually even incorporated it into the updated 8x8 distributed filter tab.
So what makes this module different from the old one?
It's extremely powerful. The VDIM gave us the platform we needed to deliver features that our customers have been asking for. We've also had a web interface available in the distributed platform. It's always offered our customers a big advantage over a dumb tap that either has no management interface or a simple CLI. That continues to exist, but it's much, much faster.
I'd like to thank you for taking the time to speak with us today. I know you guys are really busy.
You're welcome.
I'd like to thank you for your time and listening to our little show here. I hope I was able to provide you with an understanding of the cost and time savings aspect of using a distributed traffic capture system from VSS Monitoring. If you'd like to hear more about VSS Monitoring, distributed traffic capture systems, and video, then join us later this month where we'll be talking with Adi Kishore from Light Reading and Invivio about video to the 3 screens. Also, feel free to go to vssmonitoring.com to find out more about our products, or you can call us at +1 650 697 8770 and speak to one of our experienced customer support personnel who will be happy to assist you. Please tune in next month where we'll be bringing you more news about VSS monitoring and the network monitoring world.